Hey guys, there we got complex zeros and fundamental theorem of algebra, part two of what we did yesterday. All right, first part says find a polynomial of degree 4 with zeros I, negative I, 2, negative 2, and if you do p of 3, you get 25. All right, so first of all, we're really just going backwards to what we did yesterday. Yesterday we tried to find the zeros. Today they're going to give you the zeros and ask you to find the polynomial. And I hate to say this out loud, but it's probably a little more work. Okay, so here we go. P of x is going to be, I'm going to put an a in the front because I don't know what the coefficient is yet, but the 0I came from x minus I, the negative I came from x plus I, the positive 2 came from x minus 2, and the negative 2 came from x plus 2. Okay, so the bad news is you have to multiply all that out. I'm going to take the first, these are, by the way, these first two are conjugates and the second two are conjugates. Remember, from like conjugates, you can just do foo. So I'm going to multiply doing first last. X squared minus I squared. This is going to be x squared minus 4. Now, don't forget, we know I squared is really negative 1, so it's really x squared minus negative 1, so it's really x squared plus 1, and x squared minus 4. So I'm going to do FOIL there. Still got this a in the front, by the way. I have x to the 4th minus 3x squared minus 4 when I do FOIL. I did all the 4 right there in my head. And that's awesome and everything, but we have to deal with this too. P of 3 is 25. So 25 is the y, so I'm going to put 25 over here. 3 is the x, so I'm going to put a 3 in everywhere that I see an x, like this. And I'm just going to work that out to figure out what that's going to be. And when I do all that calculation right there, I get 50 for plugging it in. So if I divide by 50, I get a is 1/2. So my final solution here, my polynomial of degree 4 with those zeros and p of 3 is 25 is 1/2 times x to the 4th minus 3x squared minus 4. And if you want to distribute the 1/2, that's obviously okay too, but I'm going to leave it just like that. Wow. Next one, polynomial of polynomial of degree 4 with zeros negative 2 and 0, where negative 2 is a 0 of multiplicity 3. Remember what that means? That means it happens twice. So let's write it out here. So I have p of x equals x, that's the 0, just plain x, or x minus 0. Then I'm going to have x plus 2 cubed because it has multiplicity 3. We talked about multiplicity yesterday. So bad news is you got to multiply this stuff out. So I'm going to take a little shortcut here. I know a little shortcut to cube a binomial. I'm going to go ahead and do that right here. And if I cube that binomial, I'm going to get x cubed plus 6x squared plus 12x plus 8. And then I'm just going to distribute that x and finish up. If I distribute the x, I get x to the 4th, 6x cubed, 12x squared, plus 8x. And there's the polynomial of degree 4 that meets these qualifications, where negative 2 and 0 are zeros and negative 2 has multiplicity 3. All right, now I may give you a little hint how to do that quickly tomorrow in class, if you remind me. All right, this one going the other way again, says find all 4 zeros of that polynomial. Remember, it has 4 zeros because the degree is 4. Whatever the degree is, that's how many complex zeros it has. Start out making our list like we have been doing. The factors of 4 are 1, 2, and 4. You put those over the factors of 3, which are 1 and 3, which we just put them all over 1. 1/3, 2/3, 4/3. And like I've told you before on these videos, I'm going to guess really well the first time to keep them a little bit shorter for you. So I'm going to guess that, I don't know, let's try 2. Just to see if 2 works. I got a good feeling. 3, negative 2, negative 1, negative 12, and negative 4 here. Let's see if 2 works. Bring the 3 down. Multiply, add, multiply, add, multiply, add. Yes, look at that. It sure does. So we got to find one more because I need to break it down to a quadratic so I can actually solve the rest of it. So I'm going to try one of these fractions this time. I'm going to try let's try negative 1/3. And remember, I'm using these new numbers, the 3, the 4, the 7, and the 2, not the original ones, because I'm trying to compress this equation down to a quadratic. Bring the 3 down, multiply by what's in the box, add, multiply, add, multiply. And now I have this. I have 3x. What I have left is 3x squared plus 3x plus 6. And what I'm going to do is I'm going to get my other 2 zeros from that quadratic. So I'm going to set that equal to 0. First thing I notice is I can take a 3 out like this. So I'm thinking, what 2 factors of positive 2 add up to be positive 1? And the answer is none of them. So I'm going to do the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a, which is that right there. And if I work that out, I get, let's see, I'll get negative 7 and stuff. So I get negative 1 plus or minus the square root of negative 7 over 2. So I'm going to finish up right here. List all my zeros right here. 2 of them come from that quadratic. Negative 1 plus I on 7 plus or minus I on 7 over 2. That counts as 2 of them, okay, because of the plus or minus. Also, I got a 2 at the beginning, and I got a negative 1/3. Those are the 4 zeros of that polynomial. That was fun. All right, the conjugate zero theorem basically says if you get a zero that's a complex number, the conjugate is also a zero. So like that, I don't know if you've noticed this, but both problems we've done today have had conjugate answers. In the first problem, the 2 of the zeros were I and negative I. And the one we just did, I think we got like 1 plus or minus I on the square root of 7 over 2. Okay, those are conjugates. Those are 2 answers that are conjugates. So if 3 plus I is a 0, automatically 3 minus I is a 0. All right, so conjugate, they always come in conjugate pairs. Okay, find a polynomial degree 3 that has integer coefficients and zeros 1/2 and 3 minus I. Now here we go. If 3 minus I is a 0, so is 3 plus I. So I'm going to do the same process I've done earlier today. 1/2 came from, if you do, I'm going to do this to make it a little bit simpler. If you were to think about slide, divide, slide with the 1/2, it actually came from here, 2x minus 1. That's sliding the 2 back in front, by the way. I would get x minus 3 minus I. That's supposed to be 3 minus, there we go. And there, I don't know what's happening here. I'm sorry about this. And I would also get x minus 3 plus I because those are zeros. Now, the bad news is you have to multiply this stuff out. So here we go. Let's do this stuff. 2x minus I. One thing I want you to notice a pattern here as we go through this one. This minus sign right here is going to change the sign inside the parentheses. It's going to make it x minus 3 plus I. Same thing of the second one, x minus 3 minus I. Now, need you to look. See if you notice this. There's an x minus 3. There's an x minus 3. After the x minus 3, there's a minus I and a plus I, which means those 2 parentheses are conjugates. When I work out these 2 parentheses, I'm going to do foo. It's going to look weird when I do this the first time, but that's what I'm doing. So I'm taking the x minus 3s. That's my first. That serves as my first one, x minus 3 squared. Then I'm going to take the i's, the plus sign of the negative I, and do negative I squared. It doesn't look like it necessarily, but I just did that with those 2. I did foo. All right, so let's multiply this out. I have 2x minus 1 still in the front. Inside there, I'm going to do square, multiply double square, which would give me x squared minus 6x plus 9. Now, I squared is really a negative 1, so if I do minus negative 1, that's really a plus 1. So I'm going to take a second here. That 9 plus 1, I'm going to erase those and just change that to a 10, because that's what that is. Now, to finish up, I got to multiply one more time. I'm going to take that 2x all the way through. It give me 2x cubed minus 6x squared plus 20x. And I'm going to take the negative 1 through. Negative 1x squared plus 6x minus 10. And finally, add what I can. Nothing to combine with the cube. I have negative 6x squared, negative 1x squared is negative 7x squared. 20x and 6x is 26x minus 10. And there we go. I would say something like, that's all you got to do, because it is, but that's a lot. All right, last thing. Every polynomial with real coefficients can be factored into a product of linear and irreducible quadratic factors with real coefficients. So I'm going to show you what that means. The last thing I'm going to have you do today is, or tomorrow, is do some factoring like this with linear and irreducible quadratics. So let's see what that looks like. Okay, there's your polynomial, and it says factor into linear and irreducible quadratic factors. So what I notice is I can factor that like factors of 8 that give me 2 would be x squared plus 4 and x squared minus 2. Now here's what's going to kind of go crazy with you. Part A says factor into linear and irreducible quadratic. Now, this one, the x squared plus 4, that's irreducible quadratic. That's not a difference of squares. You're just kind of stuck there. This, however, is a difference of squares. I know it doesn't look like it because you're thinking 2 doesn't have a square root. Actually, it does. It is the square root of 2. So I can break that down, x plus the square root of 2, x minus the square root of 2. So that's the answer to part A. That's linear and irreducible quadratics. Now, part B takes it one step further and says factor completely to linear factors. So that means I can't leave the x squared in there. All right, so what I'm going to do is I'm going to solve that one. If I were to solve x squared plus 4 to see what the zeros were, I'll put the negative over here. I would take the square root. I'd get this. I get plus or minus 2i. Those are the zeros for that. So if I factored it, I would get x plus 2i, x minus 2i. And don't forget these two over here. So once I do that step right there, I have all linear factors. Linear meaning the exponent is 1 on all the x's. Okay, that's all that means. Now, one quick thing before I end this video. I know you're like, about time. I'm sorry this has been a little long, but this right here, when you get a sum of squares, if you want a factor of sum of squares, you can now do that as long as you put the I with your, I would say conjugates, the I with your conjugates, okay? Like over here, I did x squared minus 2 because it was difference of squares. I didn't need an I just need the square root. If it's a sum of squares, put the I with it, and you're good to go right there, all right? Pretty good trick. All right, sorry it was so long. We'll work on it in class tomorrow. See you, bye.